Let's find the area of the region enclosed by the graphs of the line y equals to 1/2 x and y equals to x times the square root of 1 minus x squared. It's always a good idea to try to graph this region. So let's start with the function y equals to x times the square root of 1 minus x squared. Let's look for the domain of this function because of the radical. The radical means we cannot put in negative numbers inside it. We have 1 minus x squared inside the radical. That means 1 minus x squared must be greater than or equal to 0. If it isn't, it's negative, and square root of a negative number is not defined. This means 1 is greater or equal to x squared. We can rewrite it as x squared is less than or equal to 1, and that means that x must be between minus 1 and 1. That's the domain of our function. There's nothing. There is no graph to the right of 1. There is no graph to the left of minus 1. So let's graph this very carefully by plotting some points. When x is 0, y is 0. When x is 1, y is also 0. And when x is minus 1, y also is 0. So we have these 3 points that are on the x-axis. Let's take a point between 0 and 1 and another one between minus 1 and 0. If we take a point between 0 and 1, for example 1/2, and plug it into the function, we have y equals to 1/2 times the square root of 1 minus 1/4. So that's equal to 1/2 times square root of 3 over 4, positive square root, and this is equal to square root of 3 divided by square root of 4 is 2 times 2, that's 4. So it's a positive number. Any value that we take between 0 and 1 is going to give us a positive number. Therefore, the graph between 0 and 1 is above the x-axis. So it looks something like this. On the other hand, if we take y equals to, or x equals minus 1/2, minus 1/2 will be in front times the square root. Minus 1/2 squared is 1/4, so 1 minus 1/4, and this will be minus square root of 3 over 4, which is negative. Therefore, between 0 and 1, the graph of this function is below the x-axis. So it looks something like that. Now we're going to bring in the line 1/2 x. It passes through the origin like this. So this is the line 1/2 x. The region that we want has to have borders. The line y equals 1/2 x and y equals to x times square root of 1 minus x squared. It is this region here in the first quadrant. It can't be this region here where I'm marking it with like a star. The reason is because this region that I'm putting a star in has a border 1/2 x, x times square root of 1 minus x squared, and also right over here the x-axis. That's not part of the region. We also have another piece of the area right here, another part. So there are 2 parts. It's totally symmetric. If we find the area of the region in the first quadrant, we then multiply that by 2. So we're going to need this point of intersection, the one I'm marking here. I want the x-coordinate of that point of intersection. That's going to give us the bounds of integration, and then we'll set up the integral for the area. So we're going to take 1/2 x and set it equal to x times the square root of 1 minus x squared. Now I can divide by x as long as x is not 0. We already know that x equals 0 is one of the points of intersection, the x-coordinate of one of the points of intersection. So for x not equal to 0, we are allowed to divide. That gives us 1/2 equals to square root of 1 minus x squared. I'm going to square both sides, so 1/4 is equal to 1 minus x squared. Move x squared to the left. X squared equals 1 minus 1/4, which is 3 over 4. X is equal to plus or minus square root of 3 over 4, which is square root of 3 divided by 2. We have 2 points of intersection. Over here we have square root of 3 over 2, a positive number, and right over here minus square root of 3 divided by 2, a negative number. We don't need the negative part because of the symmetry. So the area of this region now can be expressed as a definite integral. The area is equal to twice the integral from 0 to square root of 3 over 2. Now the function above is x times the square root of 1 minus x squared, and the function below is 1/2 x. And so we want to evaluate this integral. We can actually evaluate this as two integrals. The first integral is from 0 to square root of 3 over 2 of 2x times the square root of 1 minus x squared dx, minus the second integral from 0 to square root of 3 divided by 2. 2 times 1/2 is 1, so it's just x dx. Well, clearly the second integral is going to give us 1/2 x squared evaluated from 0 to square root of 3 divided by 2. So this is equal to 1/2 times square root of 3 over 2 squared is 3 over 4. So this is 3/8. The second integral is equal to 3/8. Let's look at the first integral. First integral we're going to solve by substitution. So we're going to let u equal to 1 minus x squared. When x equals 0, u is going to be 1. And when x equals to square root of 3 divided by 2, u is going to be 1 minus 3/4, which is 1 over 4. And then du is equal to minus 2x dx. So minus du equals to 2x dx. So what's the integral look like? It looks like this. The original integral was 2x times the square root of 1 minus x squared. Here the integral will run from, when x was 0, u is 1, so it's going to run from 1 to 1/4. Square root of u, and 2x dx is minus du. Now this is minus the integral from 1 to 1/4 of square root of u du. And if we change the order of integration, that introduces a minus sign, which will cancel with a minus sign in front. So this is the same as the integral from 1/4 to 1 square root of u du. Of course, this is equal to 2/3 u to the 3/2 evaluated from 1/4 to 1. So plugging in 1, we get 2/3, minus plugging in 1/4, we get 2/3 times 1/4. Square root of 1/4 is 1/2. 1/2 cubed is 1/8, so 2/3 times 1 over 8. And this is equal to 2 over 3 minus 2 over 24. 2/3 is 16 over 24 minus 2 over 24. We end up with 14 over 24, which is, dividing by 2, 7 divided by 12. So now let's bring back, the first integral was 3 over 8. And the answer is 7 over 12 minus 3/8. 7 over 12 is, again, 14 over 24 minus 9 over 24. And so the answer is 5 divided by 24. That's the final answer. That's the area of the region. For more videos, go to www.mathprepvideos.com.